All right, now we are going to solve these without using a graph. And there are two different ways to do it. There is something called substitution and there's something called elimination. So on the first one, I'm actually going to pick elimination. And the reason why I'm going to do that is because they are set up in standard form. And I have a really nice setup that I have a negative y and a positive y. So I'm going to add these two equations together. 2x plus 4x is 6x. And negative y plus y actually cancels out. Negative 5 plus 2 is negative 3. So I can divide by 6 and get negative half as my x value. I'm going to take that negative half and plug it back in for x and solve for y. So 2 times negative half is negative 1. I'm going to add 1 to both sides. And I'm going to divide everything by negative 1. I'm going to do the same thing with the bottom equation. Four times negative half is negative 2. I'm going to add 2 to both sides. I get the same answer. What does this represent? This represents the ordered pair graphically where these lines intersect. I can always check this in my calculator. 2x minus y equals negative 5. When I go to graph, I have to go backspace, go to relation, 2x minus 5y equals negative 5. Was that it? Oh, just minus y. 2x minus y equals negative 5. And then the other one was 4x plus y equals 2. Okay, I go to menu, I go to analyze, I go to intersection, go on the left, go on the right. There it is, negative 0.5, negative half, comma 4. It represents the ordered pair where these graphs cross. All right, let's look at the next one. Now, I don't have this special setup right here yet, but I'm actually pretty close. Let's look at the W's. Can I get this to kind of work out the same way I did here? If I take this bottom equation and I multiply everything by negative 2, I'm just going to rewrite this. This becomes negative 6w plus 8z equals negative 16. I'm going to add these equations together again and tell me what you notice. Six plus negative 6, or 6w plus negative 6w is 0. Negative 8z plus 8z is 0. And 16 plus negative 16 is 0. This means that they are the same line, and we can show it in the calculator. This means that they are the same exact line, so that is a infinite solution. So let's go to the calculator. And now calculator doesn't know w's and z's. We got to put x and y. So 6x minus 8y equals 16. Go to relation. 6x minus 8y equals 16. Okay, the other one was 3x minus 4y equals 8. Tab, 3x minus 4y equals 8. Look, they're right on top of each other. That means infinite solutions. Sorry, solutions. Where's my S? All right. Let's do another one. In this one, number 3, I'm going to go ahead and use substitution. So if x equals 1, then everywhere I see an x, I'm going to put a 1. This isn't set up like the other ones. That's why I'm going to do a different method in this one. So 1 plus 3y equals 4, minus 1 minus 1. 3y equals 3, so y equals 1. Well, we already know that x is 1, so that's my ordered pair. 1, 1. You can still graph this. X plus 3y equals 4. Go to relation. X plus 3y equals 4. Tab, and it was just x equals 1. We'll go to menu. We'll go to analyze. We go to intersection. Oops, what did I do? Menu, go to analyze, intersection. Oh, it doesn't like this one because it's a straight up and down. Wonder if it'll work. Oh, I just had to highlight it. 1, 1. You can also look at the table, Control T. Oh no, I don't like that. It's because I did a relation. You're not going to look at the table. Okay. In example 4, this is already solved for the variable y. So this is another time when I'm going to do substitution. So I already have a y by itself. So I'm going to take this whole entire function and plug it right in here for y. I'm going to distribute that 4. I'm going to combine like terms. I'm going to add 20 to both sides. And I'm going to divide by 5. Same thing from Algebra 1. I'm going to take my 4. I'm going to find my y value. 2 times 4 minus 5 equals y. Taking this 4, plugging it back in for x. 8 minus 5 equals y. 3 equals y. I'm going to do the same thing. Plug this x in there and make sure I get the same answer. Negative 3 times 4 plus 4y equals 0. Negative 3 times 4 is negative 12. Add 12 to both sides. Divide by 4. So my ordered pair is 4, 3. On this one, you could do substitution. You could do elimination, either one. To do substitution, though, you have to get one of your variables by itself. And if we tried to do that on this example, we would involve a lot of fractions if we were to try to get r or t by itself. I'm going to do substitution. I'm not. I'm going to do elimination. And I need to get, let's go back up here and look at elimination. I need to get, oh, it's telling me I only have 30 seconds left. Okay, I'll do the other one in a new video.